The YOLO-World model has been recently released. However, its effectiveness and its speed has been really amazing. Welcome back to the channel, guys. My name is Dhruv and I'm going to talk about YOLO-World model today. So the YOLO-World model has been recently released. It's a CVPR paper. They have been accepted into CVPR. They have open sourced their code, as well as their model has been included into YOLO Ultralytics. So if you want to ever use it, they are integrated into the Ultralytics toolbox and it is super simple to use. So in this video, I'm basically going to go over a very rough overview of the YOLO-World model, tell its functionalities, and then give you a demo. So by the end of this video, you will have an understanding of how a YOLO-World model works and how you can end up using it. Now guys, here is the paper. The full manuscript for the paper can be found here. If you are interested, you can go over the entire paper. It is very nice approach, and the basic idea here is instead of training an object detector with just images, you are training it with an input image which extracts features through a YOLO backbone. But also you have, during training time, you have an online vocabulary, and that online vocabulary goes through a text encoder. This text encoder is going to create text embeddings. It's going to make sense of the input phrase, and then together this vision language PAN is going to then merge these two features together in order to get the final output. Without going into too much technical details, let me show you how this thing performs. So guys, if for example this is your input image, now this is an input image that has never been seen in the dataset, and we're going to give it arbitrary labels. These classes may or may not be in the dataset when it was being trained. So here I just give it shoes classes, and let's see if it's able to find or detect the shoes in this image. This is zero shot, so it's never been trained. You just give it the context of the class and it's able to find and detect all the shoes in the image. Pretty nice. Now let's give it shoes and glasses. Let's see if it's able to detect the glasses. And here you see it's able to detect all those glasses. Let's add another class, a watch. And you see that it's able to detect this watch as well. These folks are also wearing watches, but it's not able to detect it. Sometimes it may have detected it, but the confidence level may be too low. However, regardless, yes, it has missed, but it's able to detect some of the watches. Now let's try another example. So here is this image, and say I want to detect people who are wearing helmet or helmets in this image. So I just put helmet and I'm able to find these helmets. Let's try hard hat instead of helmet, and it's still able to detect all the hard hats. Now guys, how is this powerful? Say that you are at a construction site and you want to monitor your workers and you want to make sure that they are wearing their PPEs, the personal protective equipments. You don't need to train a model from scratch. You can use this kind of a model off the shelf, give it the things you want to detect, and it's able to detect. Let's try a mask, and it's able to detect the masks. Here is a false detection, but overall it's able to detect all the masks in the scene. So that's how it this model has the functionality. So as an example, if you are trying to get something detected in any sort of environment and you don't really have the time or the skill set to train a model from scratch, it's as simple as just picking this model off the shelf. In the YOLO Ultralytics documentation, you can find how to use this model. They have given these examples over here, and it's as easy as picking this model from a repository, loading the weights and setting the classes that you want. Just like in this demo, you can in code set the classes that you want to detect. For example, if you are in a grocery store setting, you want to detect all the, say you want to detect fruits, you want to detect flour, you want to detect sugar or different things in a grocery store. You don't need to train a model. You don't need to go through the process of collecting data, labeling, training model, fine-tuning it, and then deploying it. You can take this model, tell it the classes that you want predicted, and if it does a reasonable job, you have a model. Again, it may not be perfect because it's not trained on that particular data, but so far we've seen without any explicit training, it's still able to produce quite impressive results. So that's it, guys. This was the YOLO-World model. A quick overview and a demo. If you go to YOLOWorld.cc, you can find their information. You can find their entire code base as well. They have open sourced their model, so here everything can be found. And also, this is the demo. So the one I showed you in this video is this one. You can go, you can try it out, and then if you want to try this model in code, you can use the Ultralytics version of it. It's pretty powerful, and it's really easy to use, just like any other Ultralytics model. So that's it for today, guys. I hope you like this video. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. Thanks a lot for watching, guys, and I'll see you in the next video.